This video will continue our discussion of double integration. We have this integral over the region R. The region R is bounded by, we have a parabola here. Hopefully you can, at this point, you can tell that is a parabola opening down, moved up 4. So if you look, I graphed that in pink here. I just did a parabola, normal parabola, upside down, moved up 4. This is a line. Crosses at 3, that's the purple there. Crosses at 3 with a slope of -1, which means I'd hit x again. I guess we need to label axes since we deal with a bunch of different x and y. So we're looking for the volume of the region that lives in that little slice there. You've seen this slice so many times over calculus, it's just turned upside down now. All right, so let's begin our integration process. I have the integral, right, of 12x to the 4th. And then we got to decide which one do we want to do first, x or y. Well, if I'm looking here, I can actually grab this piece and go up to that piece, and that's the same all the way across. These are already in terms of y. This is y equals negative x squared plus 4 on top. And then in purple, the line on bottom. So that tells me exactly what to write where. The line is on bottom, so this is y equals negative x plus 3. And then the parabola is on top. That's going to be a negative x squared plus 4, which means I got dy dx. All right, our bounds are not as simple as you would think. I almost wrote a 0 there. It is not. It is right here and right there. We have to find a way to find those bounds. Well, if I want to find where two equations intersect, I just set them equal. So I got, let's do that right here. Negative x squared plus 4 equals negative x plus 3. I'm going to get everything on the same side. I'm going to make my x squared positive. So I got x squared minus x. I minus 4. I got negative 1. This does not factor. I'm going to have to use the quadratic formula. Okay, it's negative b, so it's 1 plus or minus the square root. And if I plug all that in, b squared minus 4ac, I'm going to get a 5. And then over 2a, which is 2. So I know that this one on the right is the positive, and the one on the left is negative, and I think that's the golden ratio. I can't remember if the 2 is correct or not with the 1 plus, so don't quote me on that, but I think these are the golden ratios. So this is 1 minus the square root of 5, or the pluses, I mean, not the minus, is the square root, or the golden ratio, just the plus, I believe. All right, so I have that. Those are terrible values, but we're just going to plug them in. It's not that big of a deal. So I'm going to rewrite those. We're going to have to rewrite those quite a bit in this problem. All right, and x equals 1 plus the square root of 5 over 2. All right, this is a bit tricky, and it can go down the wrong way really quick. There is no y in that term, so I'm just going to introduce a y because it's a constant. Then I have to plug these functions in. And we still have a dx. Those are just getting plugged into the y. So I keep everything here. All right, now I'm going to plug those in, and it's a subtraction problem, so I'm going to do, 12 x to the 4th minus x squared plus 4 minus 12x to the 4th times, let me move these down real quick before I get too wrapped up in that graph. There we go. And then I'm plugging in the bottom function was negative x plus 3. And then we still have a dx here. This is going to work out for us. We just got to multiply everything out and put them together. Write my bounds real quick. And I'm not going to do this one line at a time. I'm going to multiply off to the side and then just write down my final. All right, so I got, just writing it off to the side, negative 12x to the 6th plus 48x to the 4th. Minus 12, plus, it's going to be a plus 12x to the 5th minus 36x to the 4th. We can combine like terms here. I got a negative 12x to the 6th. And then I have, I'm just checking my notes real quick, plus 12x to the 5th. And then 48 minus 36 is 12. So I got a 12x to the 4th. All right, so that's what's going here. I got negative 12x to the 6th plus 12x to the 5th plus 12x to the 4th dx. All right, I don't need those. All right, these are nice straight integrations. Makes it kind of nice. Okay, I go up by 1 and divide by the new one. So I got negative 12 sevenths, x to the 7th, plus go up by 1, divide by the new one. So this is going to be a 2x to the 6th. You can just check by differentiating to make sure it works. And then 12 over 5, x to the 5th. And then we're going to plug those in. And we're going to, why is it doing that? Hold on, there we go, okay. 1 minus the square root of 5 over 2, and then x is 1 plus the square root of 5 over 2. We'd plug x in, plug the second x in. Let's go ahead and do that. It's not going to be pretty, and we can't do anything with it after that, but we'll write it out, I guess. Negative 12 over 7ths, I'm going to plug in 1 plus the square root of 5 over 2. To the 7th. Plus 2x, or 2 times 1 plus the square root of 5 over 2 to the 6th, plus 12 over 5, 1 plus to square root of 5 over the square root of 2 to the 5th. And I'm actually going to cheat a little bit. I'm going to do this. And then using my iPad, you're going to have to rewrite it again, unfortunately. Copy, duplicate. And I'm going to, actually, let's undo that real quick. Let me go ahead and make that smaller. There we go. Now I'm going to duplicate that. I'm just going to change that equal sign to a minus. And then I'm going to go through here and change all those pluses to minuses. I cheated. All right, you'll have to go through and write it down again, but that is our answer right there. Plugging in the 1 plus into each one, and then plugging in the 1 minus and subtracting the 2. I'm not going to go any further than that because it just turns into a disgusting decimal. Honestly, I probably, if it were me in the field and I was doing this, I'd probably have the computer do it from the beginning. But if I were going to do a little bit of calculus, I probably would have stopped right here and plugged it into my calculator and got a number out, because this is a mess. But that is the exact answer. That's the only way well, if you have a TI-89 or an Inspire with CAS, it will actually spit out that a simplified version of what's there. You could also plug that into Wolfram Alpha if you're really trying to match answers with a solution manual.